Okay, since 1958, magicians have wondered whether Gilbreath shuffling can be applied more than once and still produce predictable outcomes. Well, to my knowledge, the answer given has always been no. You cannot reliably perform Gilbreath shuffles more than once and expect to have perfectly predictable outcomes. Well, I'm here to tell you that that is not necessarily the case. Okay, so maybe as a quick reminder of what the Gilbreath Principle involves, in its simplest carnation, you start with, let's say, an alternating packet of red and black cards. So this is called a cyclic packet because there's a pattern that repeats multiple times. So here the pattern that repeats is red-black, and that repeating pattern occurs 26 times. So we would call this a 26 cycle with cycle length 2. Now the Gilbreath Principle says the following, that if we reverse count any number of cards whatsoever, this is truly a free choice by the spectator, and then riffle shuffle the two halves together, there is some predictability to the outcome, okay? And if you haven't seen this before, it really is quite surprising. Okay, so we can do a traditional riffle shuffle, though this is a brand new deck here, so everything is sliding around. Okay, so we'll go ahead and just do a riffle shuffle. Not a very good one there, okay? But that's kind of the point. The Gilbreath Principle covers any and all riffle shuffling of this deck of cards in which we have reverse counted some number of them. Okay, so what does the Gilbreath Principle guarantee? It guarantees that cards taken from the top in pairs will consist of one of each color. Okay, so we have red, black, black, red, black, red, black, red, black, red, red, black, red, black, red, black, and so forth. If you go through the entire shuffle deck, each pair will have exactly one red and one black. Well, you can see how that could be the basis of many different card effects that would be very surprising to the spectator who's assuming that this riffle shuffle is going to destroy any organization to the cards that the magician had imposed on the deck. So the Gilbreath Principle says, no, not so fast. If there is a cyclic arrangement to the cards and you reverse count a number of cards and then do anything that's equivalent to a riffle shuffle, there will still be structure that you can take advantage of in very fun and engaging ways. So the question that we are now looking at is whether or not, if I put all of these back to where they came from, so put them back exactly as they were after the Gilbreath shuffle there. If we now reverse count any number of cards, so essentially perform a second Gilbreath shuffle, and then riffle shuffle these together, these two packets together, will there be structure that is guaranteed to be there after that riffle shuffle? And the answer is no. In general, there will be no predictable organization to the cards. But if we perform what I call a perfect Gilbreath shuffle, then tremendous structure is preserved and gives you power of predictability for what to expect after a second perfect Gilbreath shuffle, or a third, or a fourth, okay? So this is very, very surprising that indeed you can perform more than one Gilbreath shuffle, but this is a special one. It's called a perfect one, as I'll explain, and you can use that for the basis of countless card effects. Okay, so let's take a look at the particulars here. So I claim there are only two. So think about all the different ways that you could deal out some number of cards. You could deal out none of them, one of them, all of them, any number of them. And then you riffle shuffle those together, and so they're interlacing in just random ways. Among all of those Gilbreath shuffles, there are only two that are perfect Gilbreath shuffles. And I'll define what a perfect Gilbreath shuffle is in just a moment. Now, these perfect Gilbreath shuffles can be achieved by way of either the Klondike Shuffle, which is one I've used extensively on my channel, or a shuffle that I've called the Bessie 1-1 Shuffle, which I have also used on my channel. And it really is the case that these are the only Gilbreath shuffles that can reliably be applied more than once and yield predictable outcomes. And any Gilbreath shuffle that can achieve this same level of predictability must be mathematically equivalent to either the Klondike Shuffle or the Bessie 1-1 Shuffle. Now, although this is quite the statement, it is in fact true. So what is a perfect Gilbreath shuffle? So here's the definition. And the definition is similar for odd-sized packets. But for an even-sized packet, the definition reads as follows. A perfect Gilbreath shuffle consists of the following two actions. The top half of the packet is reverse counted, so the entire half of whatever number of cards you're dealing with, though we're assuming it's even at this moment. So in the case of an entire deck of cards, you're going to reverse count 26 of them, and then the second action is the new top half that you've just reverse counted is perfectly interlaced with the original bottom half. Okay, so we'll kind of show you that in action in just a moment. Now, when it comes to a perfect interlacing of two equal-sized packets, you may be aware of the fact that there are two ways that that can be done. So if you just imagine these two packets, this one over here, the top one here, could go above the one on the left, and then all the rest perfectly interlaced. Or this one on the top right could go underneath the top left, and then perfectly interlaced from there. So those are the two perfect interlacings. And one of those is achieved by way of the Klondike Shuffle, and the other by way of the Bessie 1-1 Shuffle. Now, the Klondike Shuffle has been in use since at least 1726, whereas the Bessie 1-1 Shuffle is a far more recent invention. Yet both hold the same status as the only perfect Gilbreath shuffles out there. Technical note regarding odd-sized packets. The Klondike Shuffle and the Bessie 1-1 Shuffle give rise to the only two perfect Gilbreath shuffles. The notable difference here in the odd-sized packet case is that for a packet of 2n+1 cards, there really is only two ways to reasonably define a perfect Gilbreath shuffle. So the first way would be that the top n cards are reverse counted and then perfectly interlaced into the remaining n+1 cards. So you just have to think you have like 4 cards over here and then 3 here. A perfect interlacing into would just mean this, right? It goes into the other packet because it has one more card over here than over here. And then the other way a perfect Gilbreath shuffle can be achieved is instead of reverse counting the top n cards, you reverse count the top n+1 cards. And then you have the remaining n cards perfectly interlaced into the n+1 reverse counted cards. Okay? So really it's the same kind of picture. So the only difference is in the first case, you are counting out less than half of them, n of them, and then perfectly interlacing them. In the second case, you're counting out more than technically half of them, n plus 1, and then having the remaining cards perfectly interlaced into those. So the point is that a perfect Gilbreath shuffle can be defined for both even and odd sized packets. And in both cases, there's only 2 that can be performed. And in the case of odd-sized packets, this first one described here corresponds to the Klondike shuffle. And then the second one here, where you're reverse counting more of the cards, more than half of them, just beyond half, that corresponds to the Bessie 1-1 shuffle being applied to the packet. Okay, so let's look at an example here. So in the very example that I opened with, where I had the entire deck alternating red-black, and then I counted out some number of cards, it wasn't even half, and then I just kind of shuffled them together in definitely a non-perfect way. Those cards were not interlaced perfectly. We saw that once that's done, each pair of cards taken from the top consists of 1 red and 1 black in some order, but we don't know the order. Now the difference here is if a perfect Gilbreath shuffle is performed, let's say by way of the Klondike shuffle, which is a shuffle that's probably more familiar to people, what will happen in, let's say we have a 32 card alternating packet of reds and blacks. So this would be, quote, a 16 cycle with cycle length 2. The cycle length is how long it takes for the cards to repeat themselves. So every 2 cards they repeat, red, black, red, black, red, black. And in a packet of 32 cards, that will happen 16 times, because 16 times 2 is 32. Now, there's a reason I chose 32 instead of 52, and it has to do with the fact that 32 is a power of 2, okay? So we'll be able to more clearly see what this perfect Gilbreath shuffle is doing to the organization of this packet. And this is something you can check easily on your own. Okay, so you have red, black throughout, 32 cards worth. Okay, so if you Klondike shuffle this, it's, quote, a perfect Gilbreath shuffle. Now the general Gilbreath shuffle tells us that in pairs, we are guaranteed that there will be a red and a black. So as you kind of come down here in pairs, so imagine these are the top cards moving down to the bottom of the packet. Okay, so here after a Klondike shuffle of this packet, you'll actually have a black on top, followed by a red, and then you'll have a red next, followed by a black, and then this pattern that we see right here of black, red, red, black repeats for a total of 8 times. So that block just repeats itself 8 times. So that means that in fact we have another cyclic packet. It's an 8 cycle with cycle length 4. Okay, so not only has this perfect Gilbreath shuffle not really destroyed things, it's actually yielded another cyclic packet. Isn't that amazing? Okay, so you can see that, of course, the general conclusion of the Gilbreath principle is in force here. It's true that as you take cards in pairs, it is true that you get a black and a red card in some order. But with this perfect Gilbreath shuffle being achieved by way of the Klondike shuffle, we get far more structure out. In fact, we get a cyclic packet, as noted here, and then even within each of the cycles, these little packets here are mirrored packets. And if you've studied other videos on my channel, you'll know that mirrored constructions or mirrored packets are extremely valuable. Okay? So essentially, it is now an 8 cycle length 4, where each cycle is actually a mirrored packet. Black, red, red, black. And that's repeated 8 times. Okay, so we've performed one perfect Gilbreath shuffle. Now, ordinarily, for a Gilbreath shuffle, you stop there. You cannot, in general, Gilbreath Shuffle this now and hope to get anything useful out of that, okay? But the point I'm making here in this video is that you can, if it's a perfect Gilbreath Shuffle, and a very easy way to achieve a perfect Gilbreath Shuffle is to just apply the Klondike Shuffle, which is a well-known shuffle in the world of card magic. So what happens now if we perfectly Gilbreath Shuffle this packet? In other words, by way of a Klondike, what do we get from that? Is there anything predictable that comes from that? Well, there is. We now get a 4-cycle of cycle length 8, and the cycles look like this. The exponents here are being used to represent concatenation to save writing. Okay, so this isn't like squaring a number. This means b squared means there's 2 black cards there. R to the 4th means there's 4 red cards in a row. B squared, 2 black cards, and so forth. Okay, so it's just a way to compress the notation of all of this. Okay, but if you look at what happens, each set of 4, as mentioned here, each set of 4 is guaranteed to have 2 red and 2 black. And that will not be the case necessarily for a non-perfect Gilbreath Shuffle. Okay, so there is something we can say after a second perfect Gilbreath Shuffle. And maybe just to back up for a second, so after a first perfect Gilbreath Shuffle, we can say that as pairs of cards, there'll be a red and a black in some order. After a second Gilbreath Shuffle, by way of the Klondike, there will now be exactly 2 red and 2 black in each set of 4 cards taken from the top. And then if we perfectly Gilbreath Shuffle that again using the Klondike Shuffle, it gives rise to a 2-cycle with cycle length 16. And here what will happen is each set of 8 cards will consist of exactly 4 red and 4 black. So it's doing exactly what you would hope it does. Each time you perform this perfect Gilbreath Shuffle, you have to increase the number of cards that you look at as a set of cards, but exactly half of those cards will be red and half will be black. That is the wondrous thing. Now, this being a 2-cycle with cycle length 16, if we perform another Klondike, it will end up not being cyclic anymore. This is not, in fact, this is the whole sequence now. So after this 4th Klondike Shuffle, we end up with 8 black cards, followed by 16 red cards, followed by 8 black cards. Okay? Now, there is something that you can still say about that. It's not cyclic anymore. The cyclic structure is now completely destroyed after the 4th Klondike Shuffle. But we can say that sets of 16 cards taken from the top will consist of exactly 8 red and 8 black. Okay? So this pattern really does just continue in terms of the predictability of the distribution of red cards and black cards among larger and larger sets of cards taken from the top. Okay? And then if another, so this is a 5th Klondike Shuffle or a 5th perfect Gilbreath Shuffle is performed, it converts the 32 cards into 2 blocks, 16 red cards on top and a block of 16 black cards on the bottom. Okay? And even knowing that, then you can take advantage of that knowledge. I mean, that's predictable. That will happen. Okay? And then it ends up that if you now Klondike Shuffle, or in other words, perfectly Gilbreath Shuffle this one more time, you arrive back to where you started. Okay? So in mathematics, we would say that the Klondike Shuffle is of order 6, because if you perform the Klondike Shuffle 6 times on a packet of 32 cards, it resets the packet to its original order. Okay? From there, it just kind of goes in circles. You'll just start over again. And what's amazing is the predictability at any step. At any step, you know exactly what the cards look like. There's no guessing. But for a general Gilbreath shuffle, you have no idea. It's only after the first Gilbreath shuffle that you have some idea as to what the cards look like. But after that first one, your knowledge of the organization of that packet is virtually gone. And certainly, as more and more general Gilbreath shuffles are performed, any and all structure is just wiped away, and you'll just slowly move towards perfect randomness or perfect chaos. Okay, before we move on to an example of a cyclic packet that has a cycle length different than 2, let's just quickly summarize what we did here. So if you have 32 cards that alternate red-black and you perform one Klondike shuffle. Now when I say Klondike shuffle, just think to yourself, perfect Gilbreath shuffle, which is what it is. So after one Klondike shuffle, what you are guaranteed to have happen is the cards will now be in an arrangement where pairs of cards taken from the top will consist of exactly one red and one black. Okay, so that is in agreement with the Gilbreath Principle. Now, if you take that Klondike shuffled packet and now Klondike shuffle it again, you'll get a packet structure where each set of 4 cards taken from the top will consist of exactly 2 red and 2 black. If you perform a third Klondike shuffle, you'll now have a packet structure where groups of 8 cards taken from the top will consist of exactly 4 red and 4 black. And then if you perform a fourth Klondike shuffle, you'll get a packet structure where it's guaranteed that cards taken 16 at a time from the top will have exactly 8 red and 8 black. And then by the time you Klondike shuffle the original packet a 5th time, you get this perfect division of red cards on top. All 16 of them will be there. And then the bottom half will consist of the 16 black cards. And then one more Klondike shuffle, you're back to square one. You're back to this arrangement of the cards, which is where you started. Okay? If you were to take a screenshot of this right up here, it would allow you to create card effects because of the perfect predictability of the resulting organization of the cards after each of these Klondike shuffles is performed. So with a little bit of imagination, you can leverage the power of any one of these results and design your own routine that will have a very surprising outcome. Okay, so let's take a look at a cyclic construction where the cycle length is not 2, because as you might imagine, 2 is kind of a nice cycle length to work with. Well, let's look at one where the cycle length is 3, and we're going to perform perfect Gilbreath shuffles by way of the Klondike shuffle again. So here, the organization of these 24 cards, this time we'll use 24, and the reason for 24 is 3 times the power of 2, namely 2 to the 3rd. So 3 times 2 to the 3rd, that's 3 times 8, which is 24. Okay, so that's going to allow us to readily see what's happening as we apply these perfect Gilbreath shuffles. So if we begin with a packet that alternates clubs, hearts, spades, a total of 8 times, so at 8 cycle length 3. If you perform a Klondike shuffle, or even more generally a Gilbreath shuffle, the Gilbreath Principle guarantees that if you take cards 3 at a time, so it's just the cycle length, 3 at a time, you'll get one of each of the cards in that cycle in some order. Now the ordering will not be preserved necessarily, as you can see. So for example, after this Klondike shuffle, the top 3 cards will be a spade, club, heart. The next 3 cards will be a heart, club, spade, and so forth. Well, because of this perfect Gilbreath shuffling, we get something very predictable out. Namely, we get this pattern of the cards, and as you can see, it's a mirrored construction, which is nice in and of itself. But this set of cards, as far as the suits, will repeat for a total of 4 times. So this will be a 4 cycle with cycle length 6 this time. There's 6 cards in here. So it's still cyclic. Okay. Also, I want to point out that I also mentioned that most of the time as we move from one to the other, the entire packet itself is, quote, a mirrored packet, which is a separate statement from saying that the cycles themselves are mirrored. I mean, when you have both of those, that is amazing, which is what we have here. Okay, and so after a second Klondike shuffle, or perfect Gilbreath shuffle, we get 2 spades, 2 clubs, 4 hearts, 2 clubs, 2 spades, and then that pattern repeats a second time. So we get a 2 cycle with cycle length 12. There's 12 cards being represented here, and it's the exact same organization of the cards' suits. Okay? And so what we can now say that we could not say with a general Gilbreath shuffle is that each set of 6 cards taken from the top will consist of exactly 2 clubs, 2 hearts, and 2 spades. Okay? So that's not something you could ever confidently conclude for a general Gilbreath shuffle. And now if we perfectly Gilbreath shuffle it a third time, by way of the Klondike shuffle, we'll get this organization. We'll get 4 spades in a row, followed by 4 clubs, followed by 8 hearts, followed by 4 clubs and 4 spades. Okay? Now, this is not cyclic anymore. That is gone. But it is mirrored, as I point out here, right, on the outer ends. You have spades on the outer end all the way to the middle. You'll have a couple of hearts, right, as far as matching suits from the outside in, right? And then if you perform a 4th Klondike shuffle, you'll get this organization of this packet of 24 cards. It'll be 8 hearts, 8 clubs, 8 spades. But it will still be true that there's something predictable you can say in terms of a generalization of the Gilbreath principle. Namely, that sets of 12 cards taken from the top will now consist of 4 clubs, 4 hearts, 4 spades. So just double what we had before. Now you can try this for yourself, and I was quite surprised when I discovered it. But you can Klondike shuffle this again and again and again, and that packet in some ways just gets messier and stranger, and there's just nothing there that you can predictably say about the organization of the cards. You can check that honestly for yourself. And one of the reasons for that is the Klondike shuffle for a packet of 24 cards has order 23, which means you have to perform the Klondike shuffle 23 times for you to cycle back to where you started. Now that was very different than what we saw before, where the cycle length started out to be 2, right? Just 6 Klondike shuffles takes you back to where you started. Here, you would have to perform 23 of them, which is no one's going to do. And there's no reason to do it, because really, after this 1, 2, 3, 4th Klondike shuffle, after that, the structure is unusable. It's not helpful. There's nothing consistently true about the organization of the suits as you move through that packet of 24 cards, okay? But it is the case that after 23 applications of the Klondike shuffle, you will finally get back to where you started. Okay, this is more of a theoretical, I guess, presentation dealing with card magic, which is something that my LinkedIn group members will likely find more interesting than the general YouTube subscriber. But there is something here for everybody. If you want to just go to key places in this video and pause the video and just contemplate what my write-ups are communicating, what they're telling us is the case about these perfect Gilbreath shuffles, there is much that could be used by even amateur card magicians that could certainly be used to strengthen their card magic. Okay, well, thank you for watching. Like I said, this is a kind of unusual one, so I don't know how many people have made it to the end, but this whole idea of a perfect Gilbreath shuffle is intrinsically an interesting thing to think about, since it's the only Gilbreath shuffle that can be reliably applied more than once to a cyclic organization of a packet of cards. Okay, and the really cool thing is the Klondike Shuffle, which is already well known in the world of card magic, is actually one of the 2 perfect Gilbreath shuffles. So that's one you can use right away. It's just that most people did not realize that when they use or apply the Klondike Shuffle, they are actually performing a perfect Gilbreath shuffle. And that being the case, you can take advantage of the resulting structures that are guaranteed when you perform a perfect Gilbreath shuffle. So it just gives you greater power of predictability that will nonetheless be very surprising to the spectator, who's just assuming that with performing a shuffle multiple times, especially something as convoluted as a Klondike Shuffle, the organization of the cards will certainly just be a mess after 2 or 3 of those have been performed. But as we've seen, that is not the case. So thank you for watching, and take a look at other videos on the Absolute Math Magic channel.